Good morning, all of you. Welcome to the Jayendra Rank Zone. In the previous lecture, we have discussed about some additional points regarding S block elements. Now we will continue with the same in this lecture also, along with some important questions. Especially these additional concepts are important for advanced level. So listen carefully. Now we are going to start lecture 7. So let us start now. Compounds of sodium. Now we are going to discuss about compounds of sodium. Compounds of sodium. Sodium hydroxide is an important compound of sodium. It is prepared by the electrolysis of aqueous NaCl in different electrolysis cells like Nelson cell, Kastner-Kellner cell, Kellner-Salvay cell. So, sodium hydroxide is also prepared by causticization process in which sodium carbonate is treated with calcium hydroxide. It forms calcium carbonate and sodium hydroxide. This reaction is reversible. So, let us see now. We have already discussed Kastner-Kellner cell, and now we are going to discuss 1 and 3, that is Nelson cell and Kellner-Salvay cell. Kellner-Salvay cell. So sodium hydroxide is prepared by causticizing process. That's why it is also called as caustic soda. So in causticizing process, sodium carbonate combines calcium hydroxide and forms calcium carbonate along with sodium hydroxide. So let us start now. So with the acidic oxides, so in Nelson cell, what happens? Let us discuss now. In Nelson cell, aqueous NaCl is being electrolyzed. Aqueous NaCl is electrolyzed. So due to which what happens? Aqueous NaCl. So it forms Na plus on passing current. It forms Na plus H plus ions and Cl minus and OH minus ions. Now based on selective discharge theory, this you'll be knowing in the 12th class. What is selective discharge theory? So based on selective discharge theory, sodium ions in between sodium ions and H plus ions will go to cathode in between sodium ions and H plus ions and chlorine ions and OH minus ions. So chlorine ions will go to anode and forms chlorine gas, and H plus ions will go to cathode undergoing reduction and forms hydrogen gas. And in the container, what is left over is sodium hydroxide. Sodium hydroxide is formed in the container. Sodium hydroxide is present in the container. So this is called preparation of sodium hydroxide by Nelson cell process. And Kellner-Salvay already we discussed. So this is called Nelson cell process in which sodium ions and OH minus ions will form. So sodium hydroxide is present in the cell, and at cathode hydrogen gas is collected and at anode chlorine gas is connected, and water left over in the container, it is only sodium ions and OH minus ions. So sodium hydroxide is present in the cell. So I hope it is clear. Next continuation. Properties. Sodium hydroxide is a base. Since already we know sodium hydroxide is a strong base, it reacts with acids or acidic oxides. So it combines carbon dioxide. So sodium hydroxide combines with carbon dioxide and forms sodium carbonate and water with sulfur dioxide. These are called acidic oxide. Carbon dioxide is acidic, sulfur dioxide is acidic, nitrogen dioxide is also acidic. So with sulfur dioxide, it forms sodium sulfite along with water, and with sodium hydroxide combines with nitrogen dioxide, reddish brown color gas, it forms sodium nitrite and sodium nitrate plus water. So this reaction is important because it is forming nitrite as well as nitrate. Sodium nitrite and sodium nitrate, sodium sulfite, sodium carbonate. So sodium hydroxide is a good base. So it's a strong alkali. So that's why it is reacted with acids or acidic oxides to form salts. So these are all salts. Next continuation. With phosphorus, this reaction is also very important. Sodium phosphorus, sodium hydroxide combines with phosphorus to form, along with water, it forms sodium hypophosphite. Sodium hypophosphate and phosphine. Phosphine is poisonous gas. Phosphine is what? It's a poisonous gas. It is used in vase. It is used in vase for clearing the mop. So that's why it is a poisonous gas. Next continuation. With sulfur. Sodium hydroxide combines with sulfur and forms sodium thiosulfate. It is called as hypo commercially. Na2H2O3. Sodium hydroxide combines with sulfur and forms sodium thiosulfate along with sodium sulfate and water. This reaction is very, very important. Commercially, it is called as hypo. Hypo means it is nothing but sodium thiosulfate. Sodium thiosulfate. It is used in volumetric titrations. This sodium thiosulfate is used in volumetric titrations for the estimation of concentration of a solution. So it is used in volumetric titrations. So please make a note of it. Next continuation. With fluorine, sodium reacts with fluorine in two different conditions. When treated dilute solution of NaOH with fluorine gas, it forms sodium fluoride, OF2. The oxygen state of oxygen is +2 here, and water. So it is a special compound OF2, that is oxygen difluoride. Since fluorine is more electronegative than oxygen, so oxygen will attain positive oxygen state. So when sodium hydroxide is treated with fluorine gas, it forms sodium fluoride OF2, that is oxygen difluoride, along with water. When taken hot and concentrated nitric acid, so both are very important conditions. Instead of forming sodium fluoride, instead of forming OF2, it forms oxygen gas. So 4NAF and H2O. So these two reactions are important. What happens when sodium hydroxide is treated with cold and dilute, what happens when fluorine is treated with cold and dilute alkali, and what happens when fluorine is treated with hot concentrated sodium hydroxide. So both are very important. Please make a note, because from this only they will frame a question. Next continuation. With halogens, chlorine, bromine, iodine, sodium hydroxide combines with other halogens and also in different conditions to produce. When sodium hydroxide combines cold and in cold and dilute conditions, what happens? It forms sodium hypohalate, NaXO. Sodium hypohalate, it is NOXO, NaXO, that is NaClO, NaBrO, and so on. So sodium hydroxide, the cold and dilute sodium hydroxide combines with chlorine, bromine, and iodine and forms sodium hypohalate along with water. Whereas with hot concentrated sodium hydroxide, that's what these conditions they'll ask in the examination. What happens when sodium hydroxide combines with hot and dilute? So what happens when chlorine is combined with hot and concentrated sodium hydroxide? What happens when chlorine is combined with hot and concentrated sodium hydroxide? This gives corresponding sodium halate along with sodium hypohalate. This reaction is also called as disproportionation reaction. What is this called? Disproportionation, because here the halogen oxidation state of halogen is, for example, I'll write one corresponding equation here. This reaction is also called as disproportionation. What is disproportionation? Simultaneous oxidation reduction takes place for only one element. So this is called disproportionation reaction. So in this example, you can see here, I'll write one equation here. So 6 moles of sodium hydroxide combines with 3 moles of chlorine gas to form 5 moles of sodium chloride plus 1 mole of sodium chlorate NaClO3 plus water. So if you see here, the oxygen state of chlorine is 0, and here it is -1, and here it is +5. So chlorine is changing from 0 to -1, decrease in oxidation number, reduction. Chlorine is changing from 0 to +5, increase in oxidation number, oxidation. So simultaneously, it is undergoing oxidation and reduction. Hence, on the whole, it is called a disproportionation reaction. So when chlorine gas combines with sodium hydroxide, combines with hot and concentrated sodium hydroxide, it undergoes disproportionation and forms sodium chloride along with sodium chloride. Sodium chloride along with sodium chloride. Same thing happens in the case of bromine and iodine also. Sodium iodide along with sodium iodide. Sodium iodate, sodium iodide. Like this you'll get. So this reaction is very, very important. Definitely they'll ask in the examination. So what happens when chlorine gas reacts with hot and concentrated sodium hydroxide? What happens when chlorine gas reacts with cold and dilute sodium hydroxide? With cold and dilute sodium hydroxide, it forms it forms again. It is also undergoing disproportionation reaction. Same thing here also, disproportionation reaction, proportionation reaction, because simultaneously here it is 0 and here it is -1 and here it is +1. So 0 to -1, 0 to +1. So when halogens, that is chlorine, bromine, iodine, combines cold and dilute sodium hydroxide as well as hot and concentrated sodium hydroxide, they undergo disproportionation reactions. uh, and in the formation of due to the formation of sodium halides along with sodium hypohalides and sodium halates. So please note down these two reactions are very, very important. So with cold and dilute sodium hydroxide and with hot and concentrated sodium hydroxide. So chlorine, bromine and iodine will undergo this process. Next continuation. With metals, sodium hydroxide readily combines with metals which are amphoteric like zinc, aluminium, tin, boron, etc. to liberate hydrogen gas. So with aluminium, it forms sodium metaluminate. With aluminium, sodium hydroxide combines with aluminium and forms sodium metaluminate. With boron, it forms sodium metaboate. And with tin, it forms sodium stannate. Sodium stannate. So these are the three different compounds it is combining with metals. So sodium hydroxide readily combines with metals which are amphoteric in nature, such as zinc, aluminium, tin, boron, etc. So with aluminium, it forms sodium metaluminate. With boron, it forms sodium metaboate. With tin, it forms sodium stannate. All the three reactions are important. Please make a note. This additional information which I am giving here is very, very important for advanced level. They can ask anything in the advanced level questions. So that's why we are discussing all these questions. Next continuation with amphoteric oxide. Sodium combines with amphoteric oxides like beryllium oxide, tin oxide, zinc oxide, etc. as shown to form sodium zincate, sodium plumbate, sodium plumbate, sodium zincate. This is called sodium zincate. This is salt. It is called sodium plumbate, sodium plumbate with along with water. So this is called sodium zincate. This is called sodium plumbate. So lead oxide, zinc oxide, beryllium oxide, also beryllium, sodium beryllium zincate, so sodium berylate, zinc oxide, the same way they undergo. Next continuation. So with salts, sodium hydroxide being basic in nature combined with salts like zinc chloride, tin chloride, aluminum chloride, etc. to form white hydroxide precipitate insoluble, while which becomes soluble for addition of excess of NaOH. So first they form zinc hydroxide precipitate, aluminum hydroxide precipitate, which on further combines with excess of NaOH. These two will form sodium zincate soluble, sodium aluminate, sodium metaluminate soluble. So in this way, you will get sodium hydroxide combined with salts like zinc chloride, aluminum chloride, etc., amphoteric salts to form white precipitate of hydroxides of those metals, which on combination with excess of NaOH forms sodium zincate soluble salts, soluble salts. Next continuation. Ammonium salts are decomposed by sodium hydroxide forming ammonia. Ammonium chloride combines sodium hydroxide and forms ammonia along with sodium chloride along with water. So this is called reaction of ammonium chloride with sodium hydroxide. All these reactions definitely they are going to ask in the competitive exam. So be thorough with all these reactions. We have selected the best reactions to understand. So it forms ammonia gas, sodium chloride and water. Next continuation. Salts of transition metals gives insoluble hydroxides. Transition metal means D block. We already know. It gives insoluble hydroxide with sodium hydroxide. FeCl3 on reaction sodium hydroxide forms brown precipitate. Copper sulfate on reaction sodium hydroxide forms blue precipitate due to the formation of cupous hydroxide. And this is copper hydroxide and this is ferric hydroxide. Ferric hydroxide brown precipitate, copper hydroxide blue precipitate. However, silver hydroxide and mercury hydroxide will decompose to the oxides upon heating. So silver hydroxide forms silver oxide plus water. Mercury hydroxide will form mercury oxide plus water. So this is a reaction of sodium hydroxide with the transition metal cations. So with the transition metals, they give insoluble hydroxides. Sodium hydroxide gives insoluble hydroxide with the transition metals, transition metal salts. Next continuation. Sodium hydroxide reacts with carbon monoxide high pressure and temperature to give sodium formate. Sodium hydroxide combines with carbon monoxide at high pressure and temperature to give sodium formate. Sodium formate. So this sodium formate is nothing but it's an organic compound. So it combines with carbon monoxide at a temperature of 100 to 200 degrees C and at a high pressure that is 5 to 10 atmospheres and forms sodium formate. Sodium formate. And sodium hydroxide combines with boron and forms sodium metabolite. With aluminum oxide, it forms sodium metaluminate. This is the reaction involved in the extraction of aluminum from bauxite. Extraction of aluminum takes place from this. So sodium hydroxide is used in the extraction of metals also. Next continuation. Next, very important compound is sodium peroxide. Already we know sodium combines with air directly to form sodium peroxide. So sodium forms peroxide along with this oxide when burnt in air, sodium nitrate. So sodium combines with oxygen and forms sodium peroxide. And with sodium nitrate also it forms sodium oxide and nitrogen gas. These are the two preparations. This is sodium peroxide again. Because here how many? Two to the four. Yes, it is sodium oxide only. Next continuation. Sodium peroxide is considered as a salt of dibasic acid H2O2 because it is resembling H2O, hydrogen peroxide. So sodium peroxide combines with water to form sodium hydroxide and hydrogen peroxide again. Sodium peroxide is a good oxidizing agent. It brings about oxidation to so many metals. So sodium peroxide on reaction with water, it forms sodium hydroxide and hydrogen peroxide. This hydrogen peroxide combined with chromium and forms sodium chromate, manganese it forms sodium manganate, etc. So all these reactions are very, very important. Please make a note of this. Next continuation. Sodium peroxide absorbs carbon dioxide and carbon monoxide to form sodium carbonate. Hence, it is used to purify air in submarines and confined spaces. Sodium peroxide combines with carbon monoxide to form sodium carbonate and carbon dioxide to form sodium carbonate and oxygen gas. Sodium peroxide reacts with dilute acids to give hydrogen peroxide, whereas with constant acid it forms oxygen readily. Very, very important. Sodium peroxide combines with dilute acids to form hydrogen peroxide and sodium sulfate. Whereas with concentrated hot concentrated acid, it forms sodium chloride and oxygen gas. Oxygen gas is formed. Very, very important, which is supporter of combustion. Oxygen is a good supporter of combustion. So what happens when sodium hydroxide combines with dilute acids? It forms hydrogen peroxide. When sodium when sodium peroxide combines with the concentrated acids, it forms oxygen gas. It forms what? Oxygen gas is important here. So these are the reactions of sodium peroxide. Under high pressure, if sodium peroxide is kept in contact with calcium hydroxide, it forms calcium peroxide. It forms what? Calcium peroxide. And with sodium peroxide combines with aluminum and forms aluminum oxide and sodium oxide. Sodium peroxide combines with hot concentrated sulfuric acid, it forms oxygen gas, sodium sulfate, and water. So these are the reactions of sodium peroxide. All the reactions of sodium peroxide are important. Next, we have extraction of sodium Downs process, Castans process. Downs process. To this process, how sodium metal is extracted? Sodium is extracted from fused NaCl. NaCl, fused NaCl. Fused means only molten. So electrolyte is 40% molten NaCl and 60% calcium chloride mixture. So when you pass electricity to this fused molten sodium chloride, it changes to form Na plus at cathode and Na plus and Cl minus will be formed. Na plus will go to cathode and undergoes reduction to form sodium metal, whereas chlorine gas will go to anode. Chlorine ions will go to anode, undergoes oxidation and forms chlorine molecule. So at anode, Cl minus changes to Cl2 by gaining electrons. By losing electrons, oxidation takes place. Already we know at anode always oxidation takes place, and at cathode we have reduction takes place. Sodium ions gains electrons and forms sodium metal. So it is called. So in Castans process, fused NaOH is used. Fused electrolyte is used, that is sodium hydroxide. In this also, Na plus and OH minus will be formed. So Na plus will go to cathode, undergoes reduction and forms sodium metal, whereas OH minus will go to anode, undergoes reduction, sorry, oxidation to form oxygen gas along with water. So these are the parts involved in Cashner's process. These are the parts involved in Downs process. Very, very important. From this also they'll ask examination questions. Now, why sodium peroxide is used in submarines? Since already we know in submarines, use of sodium peroxide cleans air and avoids suffocation, because in submarines, sodium peroxide combines with carbon monoxide and forms sodium carbonate along with water. So that's why the harmful carbon monoxide is being absorbed by sodium peroxide. That's why it is used in submarines to clean air and avoid suffocation. Very, very important question. Next. So these are the questions and these are the topics involved in sodium hydroxide and sodium peroxide. Let us see questions now based on this. I am sharing new slide so that we can write clearly all the questions and you can share these questions. So let us start with question number one. Question number one. Small moment, please. So we'll start with question number one now. All of you, please note it down carefully. Anyway, it will be present in the videos. So right now, question number one. So we are doing questions based on compounds of sodium. Compounds of sodium. So let us start the question now. Question number one. What happens? What happens when excess of caustic soda, excess of caustic soda, that is sodium hydroxide, reacts with iodine, reacts with iodine, that is excess of hot and concentrated caustic soda, hot and concentrated caustic soda. So what does it forms? I'll write the solution. Here I'm giving substitute questions so that it will be coming for objective also. So solution for this answer is, so when caustic soda combines with, so when sodium hydroxide, hot and concentrated sodium hydroxide combined with iodine, it undergoes disproportionation reaction to form sodium iodide plus sodium iodine oxide plus water. Whereas with cold and dilute solutions, sodium hydroxide with cold and dilute alkalis combines the iodine to form sodium iodide plus sodium iodate plus water. So balancing can do. So this will undergo disproportionation reaction. Disproportionation reaction. Disproportionation reactions. So this is the reaction. You have to note it down. Next, question number two. Question number two. Substance A is added to zinc sulfate solution, zinc sulfate solution, zinc sulfate solution. A white precipitate is formed. White precipitate B is formed. B is formed, which B on reaction with B on reaction with dilute acids. B on reaction with dilute acids. B on reaction with dilute acids forms forms salt, water A and B. So we can say here the solution. A is nothing but sodium hydroxide. Sodium hydroxide combines with zinc sulfate and forms sodium sulfate. This is white precipitate, white in color, plus zinc hydroxide. This sodium sulfate combines with dilute acids like HCl and forms sodium chloride along with sulfuric acid. So this is nothing but salt. So this is A and this is A is and B is form salt, water A and B, salt C, water A and B. This is C and this is B. So A, B, C, like these questions you'll get in the examination. So substance A is added to zinc sulfate solution. A white precipitate B is formed. B on reaction with dilute that is forms salt C, water A, B, and C. Water A and B and C. So answer is A is sodium hydroxide, B is sodium sulfate, C is salt that is sodium chloride. Like these analytical questions are important for examination point of view. So please make a note of it. Next question number 3. Question number 3 now. Match the following. Match the following. Let's start. Match the following now. List 1 and list 2. So match the following. List 1 is there and also list 2 is there. Let us start now. Match the following. So in list 1 we have Indian salt petri. Indian salt petri. This is first one. First one here, sodium nitrate. Second one, we have washing soda. Washing soda. Here we have KNO3. Third option we have chili salt petri. Chili salt petri is nothing but sodium sulfate dot 10H2O. And fourth one we have baking soda. Baking soda. So here we have to change 1A, B, C. A, B, C. Please note it down. A, B, and C. And D. D is nothing but here Na2CO3 dot NH2O. Next, we have fifth one. Germicide. Not germicide. Just I'm writing here, please note down. Nothing but next we have chili saltpeter. E. The option E we have. It is we have sodium bicarbonate. So answer for this Indian saltpeter, it is nothing but potassium nitrate. So first is B, one is B. Washing soda, it is sodium sulfate dot H2O. Second is two is C, and three is chili saltpeter, it is sodium nitrate. Three is A. Baking soda, it is E. Fourth is E, and fifth one automatically it will come chili saltpeter. It is sodium nitrate. Fifth one A. So I have written chili saltpeter two times, so that's what it is mistaken. So here it is fifth one. I'm rubbing it here. Fifth one it is called as globose salt. Globose salt. It is nothing but sodium carbonate. So fifth one it is a D. So answer is 1B, 2C, 3A, 4E, 5D. Next continuation. Question number 4. Next question, please note down. Name the alkali metal. Name the alkali metal which floats in water, without any apparent reaction with it. Without any apparent reaction with it. So answer, I'm directly writing the solution. Or you can write options. I'll give the options here. Option A, option A, it is lithium. Option B, it is sodium. Option C, it is potassium. And option D, it is cesium. So answer is, since the hydration enthalpy of lithium is more, so lithium floats in water without any apparent change of reaction with it. Very, very important question, this one. Next question, question number 5. So lithium is the only alkali metal which floats in water without any apparent reaction with it. Next question. Lithium on being heated in air, on being heated in air, mainly forms monoxide mainly forms monoxide only and not peroxide and not peroxide. This is due to option A, Option A, due to its hydration enthalpy. Hydration enthalpy. Option B, due to its small size. Option C, option C, option C we have tried now. Let us write option C, due to smaller ionic size, and option D, all of these. So for this, the answer is only due to its small size. Due to its small size, it cannot form peroxides. It cannot form what? Peroxides. Question number 6. So now I'll do it here. Question number 6, previous NEET questions for S block elements, because we are going to discuss. Just I'm writing here previous NEET questions from S block. So here, NEET questions I'm writing here. NEET questions from this concept. Previous NEET questions especially. Let us see now. Right. Very, very important question. What would you, this is NEET 2019 question. What would you observe? What would you observe if excess of dilute sodium hydroxide, dilute sodium hydroxide solution is added and shaken with an aqueous solution of an aqueous solution of aqueous solution of AlCl3. Very important question. This question has come from NEET 2020. In bracket I'll write NEET 2019. Sorry. You can see here NEET 2019 question. Option a permanent white precipitate is formed immediately. A permanent white precipitate a permanent white precipitate is formed immediately. That is option 1. Option 2, no change at first. No change at first, but a white precipitate is formed on standing. Next, option C, a white precipitate is formed which later dissolves. A white precipitate is formed which on later dissolves. And option D, a green precipitate is formed. A green precipitate is formed which turns red on standing in air. On standing in air. So these are the four options. This question is being built up very beautifully. So you can see here. So what happens when sodium hydroxide combines with solution is added and shaken with aluminum chloride. So with aluminum chloride, I'm writing the solution here. So sodium hydroxide combines with aluminum chloride and forms sodium metaaluminate, white precipitate along with NaCl. So sodium metaaluminate along with NaCl. So white precipitate is formed which later dissolves. This white precipitate dissolves. So answer is because this white precipitate when dissolved in water forms aluminum hydroxide. Aluminum hydroxide. So that's why the answer is third option. Very, very important question. This is NEET 2019 question. Next question. Next question number 7. Question number 7. A colorless salt. A colorless salt. This is also previous NEET question. Gives violet color. Violet color. You can just imagine. To Bunsen flame. To Bunsen flame. It is flame test. And also turns litmus paper blue. Litmus paper blue. It is blue. It is option A, sodium carbonate. It is a salt. Option B, all our salts are given. Potassium nitrate. Option C, it is potassium carbonate. They are given two potassiums. And option D, copper hydroxide. So already we know Bunsen flame is given by potassium only because violet color flame is given by potassium. But we have potassium nitrate and potassium carbonate. So potassium carbonate is basic in nature. So answer is for this option is potassium carbonate because it turns litmus paper blue. Potassium nitrate does not turn litmus paper blue. So that's why this is called answer potassium carbonate. Very, very important question. Like these questions are expected for NEET. Next question number 8. Strongest reducing agent. Strongest reducing agent among the following. Among the following. Strongest reducing agent among the following. Option A, it is potassium. Option B, it is sodium. Option C, it is aluminium. And option D, it is magnesium. So already we know first group metals are more electropositive than second group metals. So in first group also lithium is the strongest reducing agent. After lithium we have in first group lithium is the strongest reducing agent, but in the options we do not have lithium. So in the given options potassium, sodium, aluminum, magnesium. So first potassium. So answer is what? Potassium. Potassium is more stronger reducing agent than sodium. First lithium, next potassium, next sodium. Next. So these caustic soda questions we have discussed in this lecture. So many questions are coming from caustic soda. So you please concentrate more questions on caustic soda because next question is also based on caustic soda only. That is question number 9. Now we are going to discuss question number 9, previous NEET question. When crystal of caustic soda, when crystal of caustic soda, when crystal of caustic soda is exposed to air, is exposed to air, a liquid layer is deposited because a liquid layer, very, very important. This we have discussed in the lecture also. A liquid layer is deposited because option A, crystal melts. Option B, crystal loses water. So based on experiments only, we are getting more questions. Option C, crystal absorbs moisture and carbon dioxide. Crystal absorbs moisture and carbon dioxide. And option D, crystal sublimes. Crystal sublimes. So answer for this is, we already know sodium hydroxide absorbs moisture and carbon dioxide from the air and forms sodium carbonate along with hydrogen gas. So this is due to the formation of sodium carbonate. So a liquid layer is deposited because crystal absorbs moisture and carbon dioxide. So third option, crystal absorbs moisture and carbon dioxide. Like these questions are most important. Next question number 10. Which one of the following, this question is also important. Which one of the following is formed on dissolving iodine in aqueous solution of potassium iodide? Option A, it is potassium iodate. Option B, it is potassium iodide oxygen hypohalate. Option C, it is potassium KI3. And option D, it is potassium iodate KiO3. So answer is, it is potassium Ki3. Answer is what? It is potassium, because dissolving iodine in excess of potassium iodide means Ki combined with iodine to forms Ki3. Ki3, potassium triiodide. Potassium triiodide. Next question. So if you see previous NEET questions, you are getting definitely based on chemical properties mainly. Next question. Hypo is chemically what? Option A, it is sodium thiosulfate along with two water molecules. Option B, it is sodium thiosulfate with three water molecules. Option C, it is sodium thiosulfate with 4 water molecules. And option 4, it is sodium thiosulfate with 5 water molecules. So this is called hypo formula they're asking. So answer is sodium thiosulfate with 5 water molecules. How many water molecules it will form? 5 water molecules. This is the answer. Very, very important questions. Next question number 12. So we are discussing only previous NEET questions right now. Next, if sodium hydroxide, see so many questions related to sodium hydroxide. So I request you to read all about sodium hydroxide because in this lecture we discussed more about sodium hydroxide only. If sodium hydroxide is added to an aqueous solution of zinc ions, a white precipitate appears. A white precipitate appears, and on adding excess of NaOH and on adding excess of NaOH, excess of NaOH, the precipitate dissolves. The precipitate dissolves, that is becoming soluble. The precipitate becomes soluble, dissolves in this solution. In this solution, in this solution, zinc exists in the zinc exists in the option A, cationic part, cationic part. So they're asking each and everything. Anionic part, option C, both cationic part and anionic part, both cationic and anionic part, and option D, only there is no zinc left in the solution. There is no zinc left in the solution. There is no zinc left in the solution. Now let us check the answer. So it is nothing but zinc acting as anionic part because sodium hydroxide is more electropositive than zinc. Since sodium is more electropositive than zinc, more electropositive than zinc. So zinc is anionic part. Zinc is an ionic part. So answer is second option. Next question. So these are the previous NEET questions we are discussing now. So like these questions you are going to expect in the NEET. Simple questions also they'll give, and they'll give tough questions also based on experiment. Next, last question I'm discussing with this lecture. In this lecture, more questions we'll discuss in the coming lectures. Which ion forms a hydroxide? Which ion forms a hydroxide highly soluble in water? Hydroxide highly soluble in water. Option A, it is nickel. Option B, it is potassium. Option C, it is zinc ions. And option D, it is aluminum plus 3. Aluminum plus 3. So, which will form highly soluble in water? We already know it is potassium because first group metal hydroxides are highly soluble. That's why they are called as alkalis, soluble bases. So with this question, I'm ending this session. So please listen carefully. All these questions are very important to understand better. We have discussed all these questions. So in the coming lecture, we'll come up with a new topic. Thank you all.